Now continuing from the remaining exercise 2.2, question 3, sub question 5. So here we have to verify whether the given value of x is a 0 or not. So we have to substitute the given value of x in place of x, and if you get remainder 0, then it is a 0, otherwise it is not a 0. So fifth value of x is given 0 and polynomial is given px equal to x square. So substitute 0 in place of x. So if we put 0 in place of x, we will get 0 square, that is 0. Here we are getting 0. So you can say that x equal to 0 is a 0 of the polynomial px. Then question 6. Here the value of x is given minus m upon l. Minus m upon l. So you have to substitute the value of x minus m upon l in place of x. So here in place of x I have kept minus m upon l. So n will cancel and you will get minus m plus m. Minus m plus m gives you 0. As you got 0, you can say that x equal to minus m upon l is a 0 of px. Now question 7. X is equal to minus 1 upon root 3 and 2 upon root 3. Here two values are given, so you have to do 2 times. First I will substitute x is equal to minus 1 upon root 3. So in place of x, I will write minus 1 upon root 3. So 3 as it is, square of 1 is 1, square of minus root 3 is 3. This 1 as it is, this 3 will cancel. You will get 1 minus 1, that is 0. Again you get the answer 0, so you can say that x is equal to minus 1 upon root 3 is a 0 of given polynomial. Now we will check with 2 upon root 3. Now second sum of question 7. X is equal to 2 upon root 3. Now substitute the value of x in the given polynomial. Here px equal to 3x square minus 1. So in place of x, write 2 upon root 3. So 3 into 2 upon root 3 whole square minus 1. 3 as it is, square of 2. Square of 2 is 4. Square of root 3 is 3 minus 1. 3 will cancel. 3 will cancel, gives you 4 minus 1. 4 minus 1 is 3. So here you got the remainder is not 0. So p of 2 upon root 3 is not equal to 0. So you can say that x is equal to 2 upon root 3 is not a 0 of px. Similarly question 8. Here the value of x is given 1 upon 2. So and polynomial is given 2x plus 1. So in place of x, write down 1 upon 2. So 2 into 1 upon 2 plus 1. Here also 2 will cancel. You will get 1 plus 1. 1 plus 1, 2. So here also it is not equal to 0. Value of p upon 2 is not equal to 0. So you can say that x equal to 1 upon 2 is not a 0 of polynomial. Now question 4. Find the zeros, means value of x, in the following, each of the following cases. You have to find out the value of x. So first polynomial is x plus 5 given. Px equal to x plus 5. You have to find out zeros of x plus 5. So you have to write equal to remainder 0. Whatever polynomial is given, write 0. Now x plus 5 equal to 0. Take 5 on the other side. You will get x equal to minus 5. So value of x is minus 5. So zeros of this given polynomial is minus 5. And if you are asked to find number of zeros, the minus 5 is 0. But number of zeros means how many zeros? So there is only one zero. So you have to write number of zeros equal to 1. Similarly, px equal to x minus 2. Let x minus 5 equal to 0. Take 5 on the other side, you will get x equal to 5. So 0 of the given polynomial is 5, and again number of zeros is equal to 1. Third, px is equal to 2x plus 5. Let the given polynomial equal to 0. So 2x plus 5 equal to 0. Take 5 on the other side. That will give you 2x equal to minus 5. Take 2 also on the other side. That will give you x equal to minus 5 upon 2. So zeros of the given polynomial 2x plus 5 is minus 5 upon 2. As there is only one zero, number of 0 equal to 1. Fourth, px equal to 3x minus 2. Let the given polynomial is equal to 0. 3x minus 2 equal to 0. Take 2 on the other side. So you will get 3x equal to 2. Now take 3 also on the other side. That will give you x equal to 2 upon 3. So 0 of the given polynomial 3x minus 2 is 2 upon 3. And number of zeros is equal to 1. Fifth one, px equal to 3x. So 3x is equal to 0. Take 3 on the other side. So you will get x is equal to 0 upon 3. 0 upon 3 gives you 0. 0 upon any number always gives you 0. So here x equal to 0. So zeros is equal to 0 of the given polynomial is 0, and number of 0 is also 0. We don't have any zeros. 6. Px equal to ax. Take ax equal to 0. Take a on the other side. Here a is constant and it is not equal to 0. Take a on the other side, x equal to 0 upon a. X is equal to 0. 0 is equal to 0. Number of zeros also 0. 7. Px is equal to cx plus d, where c is not equal to 0. C and d are real numbers. So cx plus d gives you 0. Take d on the other side. Cx is equal to minus d. Again take c on the other side. So x is equal to minus d upon c. So 0 equal to minus d upon c. And as you got one answer, number of zeros equal to 1. Now exercise 2.3. Question number 1. Find the remainder when x cube plus 3x square plus 3x plus 1 is divided by x plus 1, x minus 1 upon 2, x plus 5 plus 2x. So one by one you have to find out whether the given polynomial is divided by this or not. Now we will take first case. X plus 1, let x plus 1 equal to 0. As it is a factor, we have to write x plus 1 equal to 0. So if you take 1 on the other side, you will get x equal to minus 1. Now substitute x equal to minus 1 in the given polynomial. The given polynomial is x cube plus 3x square plus 3x plus 1. Now substitute minus 1 in place of x. Wherever you find x, write down minus 1. Then simplify. Minus 1 cube gives you minus 1. 3 into minus 1 square is equal to 1. 3 into minus 1 gives you minus 3 plus 1. But 3 ones are 3. Now simplify this. So you will get 3 minus 3, 1 minus 1, that is 0. So whatever here you get is called the remainder. So remainder is equal to 0. You can find out the remainder in another way also, by division of polynomial. So you have to divide the given polynomial by the given divisor. Here the polynomial is x cube plus 3x square plus 3x plus 1. divided by x plus 1. This is another method. So whatever you have to write, that you can find out. Divide this first number by this, that is x cube upon x. Here you have x cube and here you have x. If you divide x cube by x, you will get x square. So write x square here. Then multiply this both the term by x square. X square into x. X square into x gives you x cube. X square into 1 gives you minus x square. Change the sign. As we have to subtract, you have to change the sign. So plus x cube and minus x cube cancel. Here plus 3x square and minus 2x square, minus x square. You have to consider the new sign. Don't consider the old one. Consider new sign. So 3x square minus x square gives you 2x square. Bring down this 3x. Bring down this 3x. Again this first divided by this first. That is 2x square upon x. Here you have 2x square, here you have x. So divide 2x square by x. Then you will get 2x. Whatever you get here, write down here 2x. Now multiply this both the term by 2x. 2x into x gives you 2x square. 2x into 1 gives you 2x. Now change the sign. Minus, minus. Plus 2x square and minus 2x square will cancel. 3x minus 2x gives you x. Bring down this 1. So here you will get x plus 1. Again first divided by first. First divided by first. And x upon x is equal to 1. So write down that 1 here. Now multiply this both the term by 1. 1 into x gives you x. 1 into 1, 1. Change the sign. Plus x and minus x cancel. Plus 1 and minus 1 cancel, give you 0. So this is remainder. So remainder is equal to 0. You can find out remainder by either of these two methods. You can use this method or this method to find out the remainder. Now second one, x minus 2. You have to find the remainder if the given polynomial is divided by x minus 2. Now as we have to divide it x by x minus 2, x minus 2 equal to 0. Take 1 upon 2 on the other side, so it will become plus. X is equal to plus 1 upon 2. Now substitute 1 upon 2 in place of x. So px is equal to 3x cube plus 3x square plus 3x plus 1. Substitute 1 upon 2 in place of x. So 1 upon 2 cube, 3 into 1 upon 2 whole square, 3 into 1 upon 2 plus 1. Now simplify. 1 upon 2 raised to 3 gives you 1 upon 8. 3 as it is into 1 upon 2 square gives you 1 upon 4. 3 into 1 upon 2 plus 1. 1 upon 8. 3 ones are 3 upon 4. 3 ones are 3 upon 2 plus 1. Now as you got the different denominators, whenever you get the different denominator, take LCM. So LCM of 8, 4 and 2 will be 8. LCM of 8, 4 and 2 will be 8. So here you have already 8. So write 1 as it is. Now here you have to 4. So by which number you will multiply 4 to get 8? So if you multiply 4 by 2, you will get 8. In the same way, you have to also multiply 3 by 2. So 3 into 2 will give you 6. Here there is 2. Instead of 2, you required 8. So by which number if you multiply 2, you get 8. So if you multiply 2 by 4, you will get 8. So you have to also multiply the numerator by 4. So 4 into 3 gives you 12. 4 3s are. Here nothing is denominator, so 1 is always there. So here you have to multiply by 8 to numerator and denominator both. So if you multiply this by 8, you will get 8. Now add it. 1 plus 6 plus 12 plus 8. That will give you 27 upon 8. So remainder of this polynomial is 27 upon 8. So this is our answer. Now third one, x. Dividing by x. So if you divide it by x, take x equal to 0. Now substitute 0 in place of x. 0 in place of x. So 0 raised to 3 gives you 0. 3 into 0 raised to 2 gives you 0. 3 into 0, 0 plus 1. 3 into 0, that is 0. 0 plus 0 plus 0 equal to 1. So remainder is equal to 1. Now fourth one. You have to find out remainder when this polynomial is divided by x plus pi. This is the symbol called pi. So x plus pi is equal to 0. So x is equal to minus pi. So substitute minus pi in place of x. Wherever you find x, write down minus pi. So minus pi raised to 3 gives minus pi raised to 3. 3 as it is, minus 5 square. Minus pi square gives you only pi square. Minus into minus becomes plus. So plus 3 pi square. Minus plus into minus. This is plus, this is minus. Plus into minus gives you minus. 3 pi plus 1. So you cannot further simplify. So remainder will be this minus pi cube plus 3 pi square minus 3 pi plus 1. Now fifth one, 5 plus 2x. So let 5 plus 2x equal to 0. Either you write 5 plus 2x or 2x plus 5 is one and the same. So 2x plus 5 equal to 0. Take 5 on the other side. So 2x equal to minus 5. Take 2 on the other side. X is equal to minus 5 upon 2. So substitute minus 5 upon 2 in place of x in the given polynomial. So in place of x, write down minus 5 upon 2. Now simplify. Minus 5 raised to 3 gives you minus 125. 5 raised to cube. 5 into 5 into 5 gives you 125. In the same way, cube of 2 is 8. Plus 3. Square of minus 5. Square of minus 5 will become 25. And square of 2 is 4. Plus into minus. Here it is plus, here it is minus. Plus into minus gives you minus. 3 5s are 15 upon 2 plus 1. Now again simplify. 25 into 3. 25 into 3 gives you 75. So you got different denominators. 8, 4, 2. Take LCM as 8. LCM of this sum will be 8. So here already 8, write minus 125. Here it is 4. In place of 4, you have to get 8. So by which number you have to multiply 4 to get 8? So if you multiply 4 by 2, you will get 8. Similarly, multiply 75 by 2. So 75 into 2 gives you 150. Here we have 2. So by which number you have to multiply 2 to get 8? So if you multiply 2 by 4, you will get 8. So if you multiply 2 by 4, you have to also multiply 15 by 4. So 15 4s are 60. And here denominator is 1. So 1 into 8 gives you 8. Now simplify this. Minus 125 plus 150 minus 60 plus 8. If you will simplify this, you will get minus 27 upon 8. So this is remainder. So remainder of this sum is minus 27 upon 8. Answer. Question 2. Find the remainder. Here also you have to find the remainder. When x cube minus ax square plus 6x minus a is divided by x minus a. So same method. So So let x minus a is equal to 0. Take a on the other side, you will get x equal to a. Substitute a in place of x. So a cube, a into a square plus 6a minus a. A cube, square of a is a square, 6a minus a. A into a square, a multiplied by a square gives you a cube. So a cube minus a cube plus 6a minus a. So plus a cube and minus a cube will cancel. And here we will get 6a minus a. 6a minus a gives you 5a. So the remainder of this sum is 5a. So remainder is equal to 5a. Now question 3. Check whether 7 plus 3x is a factor of 3x cube of 7x. Now we have to find whether 7 plus 3x is a factor of 3x cube plus 7x. So let 7 plus 3x is equal to 0. Take 7 on the other side, you will get 3x equal to minus 7. Take 3 on the other side, x is equal to minus 7 upon 3. So substitute the value of x in the given polynomial, 3x cubed plus 7x. So in place of x, write down minus 7 upon 3. So 3 into minus 7 upon 3 raised to cube 3 plus 7 into minus 7 upon 3. Simplify. 3 as it is, cube of minus 7. Cube of minus 7 is minus 343 and cube of 3 is 27. Plus into minus. Plus into minus gives you minus. 7 into 7. 7 sevens are 49 upon 3. Again simplify this. Multiply 343 by 3. 343 into 3 gives you. Otherwise you can also cancel it. 3 and 27 will be cancelled. It will be easy. So 3 nines are 27. 3 nines are 27. So you will get minus 343 upon 9 minus 49 upon 3. Again different denominators. So whenever you get the different denominators, you have to take LCM. So LCM of 9 and 3. 9 and 3 will be 9. So here it is 9. So minus 343 as it is. Here instead of 3 we need 9. Instead of 3 we need 9. So by which number? You have to multiply 3 to get 9. So if you multiply 3 by 3, you will get 9. So you have to also multiply 49 by 3. 49 into 3 gives you minus 147. Simplify. Minus 343 minus 147 gives you minus 490 upon 9. So here it is not equal to 0. So P of minus 7 upon 3 is not equal to 0. As you do not get 0, it is not the factor. So you can say that 7 plus 3x is not a factor of px because its value remainder is not equal to 0. So it is not the factor. Now exercise 2.4. Question 1. Determine which of the following polynomial has x plus 1 as a factor. So here some polynomials are given. You have to find out whether x plus 1 is a factor of it or not. So question 1 is x cube plus x square plus x plus 1. Now if you want to find whether x plus 1 is a factor or not, so if you will go in theory, theoretical part, I have told you that when x plus 1 is a factor of px, so you have to find out the sum of coefficient of the terms with odd power and sum of coefficient of the terms with even power. If both are equal, then x plus 1 is a factor. If they both are not equal, then x plus 1 is not a factor of px. So let us check for example 1. So here the terms with odd power. Odd power means whose raised to is 1 and 3. So here these are the terms with odd power. Here nothing is power is 1. So coefficient, sum of coefficient of the terms with odd power. So you have to add these two. 1 plus 1. 1 plus 1 equal to 2. Now similarly you have to find out the sum of coefficient of the terms with even power, means constant and whose raised to 2 or 4. So here constant is 1 and even power 2. So coefficient of x square is 1 and 1. So 1 plus 1. So here you got both equal. So you can say that sum of coefficient of the terms with odd power is equal to sum of coefficient of terms with even power. So sum is equal. So if the sum is equal, you can say that x plus 1 is a factor. So here you can say that x plus 1 is a factor of given px. Second one. Here the polynomial is given x4 plus x cube plus x square plus x plus 1. Now here also you have to find out whether x plus 1 is a factor or not. So first of all we will find out sum of coefficient of the terms with odd power. So these are two odd power, x raised to 3 and x raised to 1. These are said to be odd power. Now their coefficient is 1. So 1 plus 1 is equal to 2. So sum of coefficient of the terms with odd power is 2. Similarly find out sum of coefficient of terms with odd power. Even power. So this will be even. X raised to 4, x raised to 2 and constant. These three have power even, see. So if you add their coefficient, so 1 plus 1 plus 1. 1 plus 1 plus 1, 3. So this time you got both are not equal. So you can say that sum of coefficient of terms with odd power is not equal to sum of coefficient of the terms with even power. So if they both are not equal, you can say that x plus 1 is not a factor of px. So here x plus 1 is not a factor of px because both are not equal. Third question. Given polynomial is x4 plus 3x cube plus 3x square plus x plus 1. Same method. Sum of coefficient of the terms with odd power. So first find out the terms whose power is odd. That is x raised to 3 and x raised to 1. These two have odd power. So their coefficient is 3 and 1. So 3 plus 1 gives you 4. Similarly find out the sum of coefficient of the terms with even power. So these are the terms with even power. X raised to 4, x raised to 2 and constant. So now add it coefficient. 1 plus 3 plus 1. 1 plus 3 plus 1 gives you 5. So you can see they both are not equal. So you can say that sum of coefficient of the terms with odd power is not equal to the sum of coefficient of the terms with even power. If they are not equal, then you can say that x plus 1 is not a factor of px. Fourth one. Px x cube minus x square minus 2 plus root 2 x plus root 2. Same method. Find out the sum of coefficient of the terms with odd power. So these are odd. X cube, x raised to 1. These two are odd. So coefficient of x cube is 1. And coefficient of x is minus into bracket 2 plus root 2 minus into bracket 2. So remove the bracket, you will get minus 2 minus root 2. In simplification of this will be minus 2 minus root 2. Again simplify. 1 minus 2. 1 minus 2 gives you minus 1. Minus root 2. So sum of coefficient of the terms with odd power is equal to minus 1 minus root 2. Similarly, find out the sum of coefficient of terms with even power. So these two are even. Coefficient of x square is minus 1 and constant term is plus root 2. So it remains as this, no simplification. So sum of coefficient of the terms with even power is minus 1 plus root 2. So you can see that they are different. This is minus 1 minus root 2. This is minus 1 plus root 2. So these both are different. So you can say that sum of coefficient of the terms with odd power is not equal to the sum of coefficient of the terms with even power. So you can say that x plus 1 is not a factor of px. Plus 1 is not a factor of this given px.